Hi, and welcome to the brief tutorial on how to actually do bend allowances in accordance with the things like the one I've got on screen, which is the tray. Now, I know I've give you this out in class, and if you haven't got it, there should be copies available on the front desk in the classroom. But we're making a parts tray, and it's a two-part drawing. The first part shows you the basic dimensions of the parts tray with a little isometric, and the second part is a sheet with dimensions on it, which are basically blanked out so that you can fill in your own dimensions. Now, the way that we do this, and we'll be working just like the picture that's on Blackboard, we'll be working on the fact that you should have worked out what your bend allowance is on the first exercise for two bends on a piece of sheet that's approximately 6 inches long. The second part of that was to make the appropriate deduction, cut the piece to the right size, and once you bend it up, you end up with 4 inches across the back of the piece. That would prove the fact that the deduction was correct, and you can make allowances for the bends. Now, the whole idea behind that was to put two 1-inch benches on a 6-inch piece and end up with a number if you added the outside dimensions up and then subtracted away the original length. Now, just for an example, I've said, and it's going to be approximately correct, say if my allowance for two bends was 0.3 of an inch, as I put down here. Now that's for two bends. So a single bend will be half of that, which will be 0.15 per bend. Now, if you look at the diagram at the top here, what you'll notice is on the press brake and on some hydraulic benders, you actually find that the top punch is driven downwards, and there is a central point that will contact the sheet first. It's the point right under the nose of the tool. Now, you'll also note that that point is not the start of a bend. It's not the end of a bend. It's right in the center of a bend, and that the piece actually bends up on both sides of the die. Now that means that you've got two sides to a bend that you have to make an allowance for. So if it bends up both sides of the point at which the punt contacts the birth piece, we have to work out where that needs to be. So if our original size, and yours might be different, mine is 0.3, just as a rough guess, my single bend will be 0.15. Now half of 0.15 is 0.075. So I'm going to mark out on my diagram here, like this diagram up here. I've drawn a physical one here in AutoCAD. I'm going to mark out 0.075 per side of a single bend, because both added up come to the bend allowance for a single 90-degree bend, 0.15. Now, the way that we work out what this dimension should be, knowing the fact that on these drawings over here, the sides are 1.5, the back is 6 inches, and the last side is 1.5. You can see these arrows down here. We measure from this edge. Now, it's important before you start that if you've got yourself a piece of steel a little bit bigger than you actually need, okay, so if it's a little bit bigger, it'd be something over 6, 7, 8, 9, so something over 9 inches by 7 inches. Go around it with a square and find your squarest corner. You need a nice square corner, and we're going to make our marks or make our lines on this piece of steel going across the sheet one way and going down the sheet the other way. I've shown these arrows to show you how to use these little deductions that I put on here. So what's the first side of the flange? 1.5 inches. So coming from this squared edge off of here, we move in 1.5 inches, but we then deduct however many of these numbers you go past. Well, we've only gone past one when we get to that line, because the other 0.075 is the other side. We haven't got there. So it's 1.5 minus 0.075. You take that number and you place it up here, because that's how far you're going to have to measure in from the side of your sheet. Now, as far as getting the second line on, so we've got the first one on, we now say it's 1.5 inches plus 6 inches, meaning 7.5 to that point. But we've gone past 1, 2, 3 of these 0.075s. So it's actually 7.5 inches less 3 times 0.075, which I think is like 0.225, right? So it's 7.5 inches less 0.225. Once you've got that number, it goes in there. Okay. Last but not least, if we add up the 1.5, the 6, and the 1.5, we end up with 9. But because of that, we're going past all 4 of those numbers, so we have to take off 0.3. So if that's 9 inch less 0.3, the overall blank size is effectively 8.7. Okay, so that's the way you put these numbers down. This is the reason why you put that number down, and then you make the appropriate deductions to find out where your line should be. Now, even on AutoCAD, if you wanted to work it out on that first, if you go up here, there is a calculator, and I've got it on screen already, but there is a calculator there that you can use. Okay, so you can draw this thing out. The next answer to your question is, if I draw it out, can I cut it on the plas? No, because we've got these little tiny holes and things to put at the bends, right, the corners, and they need to be done before you even notch out the corner. We need to drill these holes, then notch. Okay. Now, the prime directive of getting these flange lengths right is when you put it in the press brake and we put the bend in, this edge should come up dead level with this edge that comes up. If you look very carefully at the top view over here on the right, the bottom picture, you'll see that they're actually like an open corner. It's edge to edge on the inside. That is how tight you can get any development if you do the appropriate bend deductions. And that's what we're looking for. If there's a bit of a gap, not too much of a problem. If you totally screw up your corners, you're going to end up having to weld up to about 1/8 of an inch of gap. Now, not that I want this thing welded. I'm just saying, if you were making this for a welded piece, a big open corner on a piece of thin 14 gauge is a nightmare. You'd probably have to throw it away and start again. So the correct calculations of how to make these deductions, then work out both your blank size and the appropriate position of your bends and your notches that go with your bends, is pretty important. Now, on this piece, it's a very small part. We're only talking about a parts tray with 4 bends. Take a look at this week's exercise that's coming up, which is the flange box. There are a lot more than just a few lines on there. There's twice the amount. So every time you go past one of these like 075s to get to this line, you have to deduct it. Then if you go past the second one, you have to deduct 2 of them. Go past the third one, 3 of them. Fourth one, 4 of them. And so far, all the way up to 8 when you're putting the lines down on the sheet. You go across the sheet first, then you come down the sheet second. And that will give you both the blank size and the appropriate positions for the notches. Now, I'm not sure of an easier way of doing a video on this. It's going to take a little bit of getting used to lay out sheets and things. But I just want you to make it right. and hopefully this will be sufficient for you to be able to lay out your sheet correctly. Okay, so grab a piece of steel, do the calculations on that second page first, because I'll want to see the calculations. Remember, if you want me to check your numbers before you commit to actually making the part, bring it to me. I've actually got like a crib sheet, an answer sheet in my office that I wrote out before I left, and it's got the appropriate dimensions on there that I would make. Okay, so I'll see you in class.